Here we have to compute the following integral, and notice that it contains a fifth root and a natural logarithm. We've seen something similar before. It's time to do a bit of algebra. For one thing, the fifth root of something, in this case x minus 2, is simply that thing to the power of a fifth. So we have x minus 2 to the power of a fifth. And then we have a natural logarithm. The natural logarithm of an exponent, and we've already done this kind of thing before, of x minus 2 to the power of 1/5. We just take the 1/5 in front of the logarithm, and it's 1/5 the logarithm of x minus 2. So if we put this back in here, what we're going to get is that this is equal to, now the fifth that can come in front of the integral sign, so it's 1/5 the integral of x times the natural logarithm of x minus 2 dx. Now this we're going to do with integration by parts. And let me remind you of the formula of integration by parts, and that is the integral of u dv is equal to uv minus the integral of v du. I don't want to keep dragging the 1/5 with me throughout, so let's just take the integral of this bit first, and at the end we'll remember to do the 1/5. So I'm continuing down here with the integral of x times natural log of x minus 2 dx, and it's pretty clear that we want to take this as u, and this with this will be our dv. First we need the uv. Now u is natural log of x minus 2, but what is v? We don't quite have v. We know that dv is x dx, so in that case, by taking the integral or primitive, we get that v is 1/2 x squared. We don't need the constant at this point. So times 1/2 of x squared, now that's our uv, minus the integral of v, which is again 1/2 x squared, and du is going to be the derivative. Du will be the derivative of this, which is 1/x minus 2 times the inner derivative, which is just 1. So here it's a 1/2 x squared times du times 1/x minus 2 and dx. Oh, of course, the dx here, yes.